Okay, another thing. Okay, I will mention the quiz later on. So another thing about the class. Eventually, we will have a physical class, but sometimes in a few meetings, maybe we will have an online class. But after we have the physical class, mostly it will be physical. But sometimes, if we need, we will go back to online, maybe several times. Okay. Uh, Also, the Google Meet for uh, for today. Um, Especially, I saw that a lot of you are not using your GApps account. GApps. Let me write here so you will understand what I'm saying. If you don't understand my words, so use GApps account to join Google Meet. Okay, and then if you you are denied, then it means that you are just using your Gmail. Then you need to change to GApps account. You're denied if you are denied, or if you use regular uh, Gmail, you will be denied. Okay, and don't ask me like why I cannot go to your class. Okay, I think repeat me so many times that you need to just use the GApps account. Okay, and if you are using the regular Gmail, uh, I will deny you. Okay, so please use your GApps account, and also please join the Google Classroom. I think some of you still not joining the Google Classroom, so it's up to you. If you don't want to have like score from the Google Classroom, that's okay for me. And then maybe you're asking, oh, Professor, I haven't done this assignment. Well, because you are not inside, then you just skip it. For me, that's okay. But I want to help you. Okay? I want to help you. All right. Uh, I hope you guys already scanned the attendance for today. Let me just make some review for what we have done in the um, last week. Uh, the small quiz. Okay. Okay. So first we have this piecewise defined function, and the question is just you need to find which one is false based on the functions. Okay. So you'll see from the options given, uh, there are some limit evaluations for options here, A, B, C, D, and how to read this. Uh, for example, option A, limit as x approaching 3 from the left. Okay, I hope you still remember that. From the left, so we have uh, 3 is here, right? So from the left, probably it's going to be um, from the left of 3. So let me go and make some. So this will be 0, this will be 3. So 3 from the left, from here, right? So probably we're going to see this one. And if we look at this, then it's true that this is going to be 0. And you can check one by one the options, and you will see that when you reach the number C, there will be a little bit uh, weird thing happen in number C, for option C. If you look at when limit approach 0 from the left, you will get this. Okay, you will get 0. But when you get uh, approaching 0 from the right, you will get 3. And this means limit doesn't exist. Oh, by the way, I checked some of your homework and I need to make some clarification and confirmations. Okay, there is a difference between this and DNA. This is not the same. Okay, if you find the limit, something f of x and something blah blah blah, approaching something, and you get you substitute the a, and then you get that it's actually this or maybe negative infinity, and this is your answer. It exists. Okay? It's like when you have this, and then maybe you have this is maybe 2, and then you have going there, and then you have the asymptote here, and you want to know what's the limit when. Okay, sorry. All right. Sorry for the connection. Sorry. We're still here. Okay. So when you have this, okay, when your x approaching some number, and then when you check the limit, oh, it's getting bigger. You can just write this. Okay. Or if you want to write in words, the limit results is getting arbitrarily large. It's also fine. It's also fine, or just simply the infinity. Okay? But remember, because we already learned that we have the infinite limit and we have limits at infinity, uh, we can write infinite or negative infinite. Okay? And doesn't exist means maybe the one limit you have, maybe this, and maybe this is a, and then this is a from the left, and this is a from the right, and maybe this is this. Now we can make sure from the left hand and right hand limit that this is doesn't exist. Okay, so I hope you get the conclusions. Okay, how we can write some limit to be infinite or some limit to be doesn't exist. So again, let me make sure to you that this is not the same. Okay. Okay. All right. Okay. So the second questions we have limit as x approaching infinity, and we have this e. Okay. Have this e. All right. We can have uh, this power here, x minus x squared. We can let that equations equal to some variables, and then we can look at the variable here, and if we factorize x, and we have 1 minus x, right? And uh, the logic on how we are getting this is see that 1 minus x, okay? If you are imagine that x is really, really large, larger than 1, this will be resulting in negative, right? If negative, then if this is positive, then the result will be really, really negative or a large negative. Okay, so when x is approaching infinite number, then our t will be negatively large. Okay, so when it's negatively large, we can exchange this, becomes t. Okay, okay, the one who are just entering the meeting, if you are using your Gmail, regular Gmail again in the future, I will not allow you. Okay, so please use your GApps account. Okay, so limit as t approaching negative infinity of e with the power of t. This by definition we have learned before that this will be equal 0. You can also imagine this from uh, the exponent graph. Okay, when you have a graph when x is going to be approaching to a negative infinity, it will be going to be closer to. Okay, all right, so it will be 0. Okay, the I think the last questions uh, we can also say here, okay, uh, oh, now to make it uh, more because I don't want you to be confusing about this part here. Okay, so actually you can write doesn't exist. Okay, but in some cases, for example, if you want to have the uh, because it doesn't say which function this is, f and g. Uh, if you can draw the asymptote, I think it's better to say that uh, the limit going to be infinity. Or you can also say the limit at x. You need to write uh, conclusively limit at x, for example, x equal a here. The limit at x equal a is undefined. Now this is true. Now this is true. But if you just write maybe uh, maybe you can write like limit as x approaching 5 is undefined. or doesn't exist. Okay, this is just to make sure that you can differentiate the uh, the left hand limit, okay, and the right hand limit. Okay, if this is not the same, if this is not the same, then definitely you can write this doesn't exist. Okay, so it depends on the case. Okay, whether you need to write as doesn't exist or you need to write as getting large, infinity large, and you can write infinity. Okay, I hope you understand my point. Okay, my idea. So the idea is you need to write really precise what is the conclusion. Okay, if you just write, for me this is I think not good example here. You need to write in conclusions limit as x approaching 5 is undefined or doesn't exist. Or if you want to make more precise, you know the left hand and right hand, and this is true here. Okay, because doesn't exist is again it's not the same as infinite or negative infinite. Okay, but limit at that point is doesn't exist. Okay, all right. Okay, okay. I hope you don't get confusion. Okay, as long as you write the conclusions precisely and um, yeah, as long as you can write the conclusion precisely, then I think it should be okay. It should be okay. If you write like no, there is no explanations, and then you just write the conclusions. Sometimes when people see your conclusions, if you're writing the conclusion maybe too short, maybe it will have some misunderstanding. Okay, I saw some of your homework, and I think that is the case here. Okay, now why this is true? Okay, so the answer is true. Okay, the answer is true because we already defined the limit of f and limit of g becomes 2 and 0. We already know it has an exact number, and then when we divide them, it will be at that point at x approaching 5, it will become doesn't exist. Okay, all right. Okay, again, I've asking, uh, I'm asking you last time when you want to have a physical class, and I already also mentioned in the Moodle. So probably next week, Tuesday, 19, okay, 19, uh, we can have the um, physical class. Um, and also, I just remember that I think you guys also mostly took the Friday class. Uh, oh no, your class is Tuesday and Thursday, so no problem. So you want to have like as soon as possible and online all the time. Actually, uh, because online have more students that choose this. Okay, so I'm actually giving you options. Okay, so I'm still using the Google Meet for online. So if you prefer, maybe sometimes you want to go for online, you can go for online. Except, okay, except for exam, for physical exam, for physical exam. For physical exam, you need to come. You need to come. So it's up to you. Okay? If you want to have still have online, you can have online. And when you have physical class, I will be at the class. Okay, next week I will be at the classroom, and I will still open the Google Meet if you want to join using the online system. That's okay. And you need to use all the time your mask. Let me remember your mask and scan the QR code. I think you already go to the class, right? Scan QR code in class. Yeah, just to remind you. Okay. Um, okay, I think we can move forward, and then I hope we can finish the chapter 2 today, and maybe Thursday we can have some introductions for chapter 3, which is the uh, more elaboration in derivative. Okay, well, let's move forward. So the chapter is about the derivative as a function. This is actually chapter 2.8. So if you remember, chapter 2.7 is about the tangent, rate of change, okay, and so on. And now we have the derivative as a function. So we will look at the derivative first. Okay. Yeah, we will have some definitions. Okay. Okay. Now we will start with our definition of derivative that I think we already mentioned this last time we have class last week. So derivative, or simply we can write f prime, okay, f prime of x is actually limit as h approaching 0 of f x plus h minus f of x over h. H is a distance from some point to another point that you are looking at. And then you imagine the point being closer to 0. Okay? So this distance is getting very small. Yeah, for instance, we remember that we have PQ, and then we move Q closer to P, and then the distance here initially is H, and the distance is getting smaller and smaller, and eventually reach 0. And when Q is getting closer to P, it actually signifies the the tangent at P, right? Okay. So we can also consider that derivative is also a tangent at this point P. All right, that's just a little bit review. Okay, we call this derivative, or we derive this because it has been derived with quotes. It has been derived from f of x by limiting operation in these equations. Okay, and probably the domain. Uh, and the domain of f prime is the set in which the f prime exists, or any x that is making the f prime exist, n may be smaller than the domain of the original functions, okay? Because it's already been derived, so the domain probably smaller. Okay, now looking at this random function here, uh, I'm having the y equal f of x, okay? And this is just a random function. What we are going to do now is to make the uh, derivative from the original function here. Okay. Firstly, to look at how derivative looks in the original function, we need to remember that the original definition is through the tangent, right? Through the gradient, through the slope, okay? So maybe I will draw some slope and how it is going to be changing over the time or over the x-axis, okay? So let's see from here, let's say this is our point here. Let me draw here. Maybe I will make it more thinner. Okay, maybe there. Okay, so probably there is my tangent here, okay? And maybe about here. And that's also the tangent. There's also a tangent here. And eventually, you will see that the tangent is reaching here. It's making a horizontal tangent. Or maybe let me just make it horizontal for this one. Okay. So from here, remember when you have a slope that is looks like this, the slope is negative, right? Slope is negative, and then when it's reaching like this, it's still negative, but it's getting closer to 0, right? And when you have the horizontal one here, the gradient is 0. Okay, hope you get the idea. And after 0, it will become positive. So let's draw the positive here. Okay, that's the another gradient here, and then maybe gradient is about here. Another one here, another one here. Now look at the gradient here. The gradient here it's become positive. Okay, it's increasing, right? It's increasing, but then it's getting closer to 0 again. So it's decreasing. Okay, you get the okay. How to understand the graph is you need to get the feeling of the gradient when it's going to increase, decrease, and it's really important because I think in the next few sections we will learn how to sketch a graph through a calculus, through a derivative. Okay, and then eventually we will have something horizontal here, which is this is the gradient is equal 0, and then we are going to have negative for the slope. So it's negative, the slope is negative, negative, negative. Still negative here. And eventually it's getting closer to 0, which means increasing. The negative is getting closer to the positive one, or in this case 0. Maybe here will be around 0 here, but we are not sure, so let me just be making like that. Okay, now that's how we approach the original random functions, and then look at the change in the derivative. Okay, Now, if we look at what's the actuality, okay, let's say at this point A, the gradient is -1. Okay, it's precisely uh, similar with the line of y equal -x. Okay, precisely like that. And then at point B, it's horizontal, it's 0. At point C, it's equal 1. And point D making 0 again. And probably at point P here, we have some negative gradient, which is a -2/3. And then if we are going to have the derivative, so let's see, okay, these two graph, okay. So the first graph, okay, maybe it's let me write one more and make it bigger. Okay. So this will be y equal f of x, okay, and this is y equal f prime x. Okay. So this is the sketch of its derivative. Now, how we are going to observe, and identify whether it is true that this is the derivative of our original function or not. Okay. Now, look here, we have the gradient is negative at A. Okay. Let's look at the line from point A to A prime. Okay. And of course, you will see that this is negative area, right? This is 0. Okay. And this is positive area. So we are start from the negative part. Okay, so that's true. This is negative. Okay. And then we are moving, getting closer to 0. Okay. So we are moving, moving. And then I think also we can see from here, it's getting increasing. Okay. See that this is actually increasing. The minus is getting plus, right? And eventually it reach out this b prime, which is, this is 0. Okay. So precisely at b prime, it's 0. Okay. And then it's going to have c prime here, which is, this is m equal 1. And why we have now at c prime, you will see that from increasing here, it's going to have decreasing point. Okay. Look at the c. Okay. Look at the change from b to c and c to d. Okay. From b to c, we are start from the horizontal one, and then little by little, we are getting increasing. So plus. Okay. So it's getting somewhere here. So this plus. Okay. And then you get the C, and then from here you get that. Okay. You get, it's still positive, but it's decreasing. It's actually going to be 0. That's why you are going to have a decreasing functions. Okay. It's not in negative area, but it's still decreasing until it reaches the d prime. And d prime is, of course, the horizontal tangent is 0. And it's true that it's equal 0. So m equals 0 here. And after this, from d prime to some point here at p, we are going to have a decreasing point, and we still have a decreasing point here. And we are on the negative area. Okay. To understand this part, if you're still confused about this, what is the negative, this is related to the second derivative, which is we are going to learn eventually later. But if you want to understand more here, we can also think of a second derivative, or f double prime. But I will not going into detail for now. But this is just for intermezzo for you to have more information. Okay, so we are now here, and then from somewhere here, if we look at this point here, you see that this is from here going to be decreasing, and then from here we are going to have, let's see here, uh, we are going to have going to be closer, probably zero here. There will be maybe a zero here, probably. But we are not sure because it's the graph is cut at this point. Okay, but we know that from this negative, it's become more positive, right? And becomes zero eventually, maybe. Okay, and that's why it's getting closer to zero here, because it's keeping an increasing from this point here. From this point here, let me just write q. Okay. There's the text here, the graph didn't mention any point here, but I will mention this is q. So after this q here, let me write, let me draw the line. Okay, and let me show you that this is the q prime. So after the q prime, you will see that it's decreasing and eventually leading to zero in the gradient, or in the derivative. Okay. Okay, I hope you get the idea behind the, at least from graph observations. Okay. Okay, there are some examples, finding the f prime using the limit notations. Okay, let me just make an example for you to uh, give you an idea how to find the derivative using the limit notations. Okay, if, okay, let's say we have f of x, and then find the f prime using limit definition, which means we are going to have this and plug in all the information into limit as h approaching zero. So the process of derivative is actually using this limit definition. And we are going to have the functions, this function here. So substitute x plus h. Okay, and then we need to simplify. Oh wait. I think this is the wrong functions. Should be this cube. Okay, cube. Okay. Okay, now we need to make out the all the expansions. So this will be x cubed plus 3. Okay, I think that will be our equations. Let's check out the All right, and then we can make this we can make the h going out. Okay. And then we can cancel this, and then all will be this will be 0, so we will have 3x squared minus 1. Okay. Okay, so our derivative now still using the limit definitions, which is more calculations that probably the one that you already knew, the derivative, the simplest one. But you need to remember how the definitions at the beginning for derivative, okay, using limit. Because sometimes you need to use this property to check and to confirm some calculations. Okay. 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 We can move to next section. Okay. Maybe let me just maybe remind you some other notations that we might have. Sometimes we are just using f prime. You can use that also, or y prime is also fine. Or you can also write dy over dx, or maybe df over dx, or maybe d dx, and then f of x here. Or you can also write d and then f of x, or maybe dx. This is I think for the next calculus. Okay. I think we are more likely to use this 3, or maybe this. Okay. Okay. I just read email from some of you. One of you, you still cannot join the Google education account. You need to apply through the computer center, NTSA computer center. As long as you're a student of NTSA, you can apply for free. You just to fill out the form, I think, and you just need to write your student ID, and you can get your Google account. Okay. I don't think it's difficult. Okay. You can check the article on the computer center. Okay. Okay. Yes, that's the article. Thank you. Thank you, Yolan. Yeah, you can look at the article here. Uh, that is basically how you can apply for the Google account. So yeah, if you are maybe confusing, you can ask maybe your friends, your classmates, uh, how to join that one. Okay. All right. Another thing in the notations, we can also write this in terms of, so we can rewrite in terms of, um, we call this is the Leibniz notations. So this is the Leibniz notations. The small d here is the Leibniz notation. So we can also uh, write as this is. Okay. And we can also write if you want to evaluate at some x, like for example x equal a, which means we are going to evaluate the derivative at x equal some exact number. Okay. Or we can also write in terms of like this. Okay. Like a bold bracket here, and then x equal a. It's the same notations. Okay. So this means the vertical one, x, uh, the vertical bar is meaning evaluate at x equal a, or here. So also same meaning. Okay. Okay. I think notations not a problem, right? Okay. Definitions. Okay. A function's f is differentiable at a if f prime exists. So this is important definitions. Okay. So function will be differentiable if the f prime exists. It is differentiable on open interval from a to b, or you can see the bracket here, all at all real numbers. Okay, if it is differentiable at every number. Okay, okay. To understand these definitions, let's see our functions of absolute value of x. Okay. If we draw the function, the absolute value probably this, that, and also this. Okay, probably that is the absolute value of x. This is okay. Now the questions will be um, how to compute the derivative. Of course, the absolute value we can evaluate based on the limit from the left side and the right side. So we can see that it is actually going to be x and negative x, right? This is okay. And we can also write in terms of limit. And let's say we are going to have our f prime. Or maybe let's start from here. I think this is better. Or maybe I will move this to here. So as limit going to be infinite, or let me start with derivative. I think this is better for you to have the understanding. Okay. So f prime. Okay, let's start from there. Okay. Okay, let's say we are start from the x greater or equal 0. We have to, I think, to make it the same as your textbook, let's just make it same. Actually, it's the same if you switch the sign, but I want you to make sure it's the same as in your textbook. Okay, let's start with x greater than 0. So this will be all positive here. So we have x plus h, and then minus x, and then over h. Okay. And we will have limit sh h over h, and it will be equal 1. Okay, equal 1. Okay, another one, if we have x less equal 0, write the same thing here. And this will be negative x plus h, and negative x, and then h. And this will be negative limit sh going to 0. This is h over h, not minus, and then this will be negative 1. Okay. Okay, now we are having different results now. We are having different results. So we can compute at 0. We need to make this equal for the continuity, right? To make it, or let me write here. For the functions to be continue and derivable, we need to make this equal now we have this statement here. If this is exists, if exists. But then, okay, compute left and right limit. We will have, so from here, we're going to have limit as h approaching 0 from the right. We will get h over, or maybe let me write step by step. This is one, and another is again, it's the same result as we are calculating from here. Okay. Since this is different, so we can make a conclusion here that this is does not exist. F is differentiable at all x except x equals 0. Okay. And we may have a formula for f for the derivative. It will resulting 1 and negative 1. This is if x greater 0. This is x less 0. Okay. So it's not true that this is having equal, so this should be less. Okay. It's proven by there will be no uh, the derivative at x equals 0 is not in existence. Okay. And if we draw the graph for the derivative, the graph will be and this is open interval. Okay, this is 1, this is negative 1. This is f prime x of uh, the absolute value. All right. Now, what I want you to keep in mind is the graph here. It is it's actually continuous graph. Okay, because you can make a graph like this without taking out your pen, right? So you can make like this, right? Or maybe this also, it's continuous. It's continuous functions, right? But continuous functions doesn't mean that it is derivable. Okay, so continuous and derivable is different. Okay, if the graph is continuous, or if the f, okay, so let me write here, if f is continuous, f is differentiable, not necessary, not necessarily true. From what we have learned here, from the absolute value of x, at this point here, at x equals 0, the function is not differentiable. Okay, so the next theorem will be very important to make in our definition. So if f is differentiable at a, then f should be continuous at a. So we need to provide that f is differentiable. Then we can make a conclusion, oh, it should be continuous. If not, then so if not differentiable, it may be continue, but not necessarily continuous. Okay. Okay. I hope you get this very clear. Okay. All right. Okay. Any questions? Any questions? Okay. Okay. Let me continue a little bit. Uh, I think we can finish the chapter 2 today, and then a brief intro for chapter 3. So, but before that, let me give you some example. All right. Let me give you a tree graph. Okay. Uh, A, B, C. It already has a name. Each one has a name. Corner, continuity, vertical tangent. All right. Now, imagine this is all three cases that might happen in a functions in a functions. So this is how a functions fail to be differentiable. Okay, first, if you look at this, it's also similar with the what we have done before. It has a sharp corner, like in that's this absolute value x like this. At this point here, at x equals 0, it is not differentiable, right? So this is also true for this. So whenever you find any sharp corner in your curve, then it's not differentiable. So not differentiable. Okay. Another way to look at is when you have this, okay, discontinuity. Of course, there will be no you will not be able to differentiate at this x equal a, right? So this is all not differentiable at x equal a, okay, to be precise. And also, if you have the vertical tangent, it's also not differentiable. Do you know why? Because we already make the definition of the derivative, which is this, right? This is also tangent. This is tangent equals 0. But what happened when you have this? The vertical tangent here. What is the gradient? Right? The gradient is actually the infinite form. So which means that there will be no derivative at this x equal a here for vertical tangent. So this is three ways that might happen, and the result is all three will be failing to be derived. All these three function is not differentiable at x equal a. Okay, let me go tell you why this is not differentiable. Okay, let me go through the functions in this point here. Okay, if you look at here, see the let me change the. If you look at here, this is the gradient. Okay, the tangent, the tangent, the tangent, right? So you will see that every point here, it has a tangent, right? You can see it also can, you can also see the change of its gradient every time it's moving, right? And of course, at this exact point here, if you look at, if we zoom and zoom and zoom, if we're getting closer to the point here, it is, you will notice that whenever you zoom in for any curve you have, if it is differentiable, when you zoom in, you will see that the curve itself becomes a linear and become its tangent. You get my point, right? So we can also have some linear, we can write approximations the uh, from the zoom in, okay, from the f of x. We can have linear approximation from the f of x through the f prime. So we can, so one of the example on how the f prime is useful. So this is useful. This is useful for linear approximation. Okay? So we can approach this and make some numerical method. Okay? But we will discuss that later. But the more important here is you will see that this point here it's is really similar to the tangent. It's tangent itself. Okay, it tangent itself at this point. Okay, let's compare with this type of graph here. What's the problem here? When you zoom in, okay, when you zoom in, cannot zoom in, okay, and then zoom in. What happened here? This is really making your definitions becomes not ideal, right? For example, you have from here is you have the derivative here, you have derivative here. Derivative here is positive 1, derivative here is negative 1. So the question is, what is this? Positive or negative? We don't know, right? That's why this is fail to have derivative. That's why every sharp corner, they cannot be differentiated because we don't know what's the actual tangent. Is it positive gradient? Is it negative gradient? Is it zero? We are not sure, right? We don't know. That's the fact. So we can make a conclusion that it is failing to have differentiable at x equal this exact number here, maybe x equal a. Okay? So it's failed to be derivable. It's failed to have a derivative there, right? Okay, I hope you get the idea. Okay. Okay, any questions? Any questions? Okay. Okay, let me move on and go for some notations about this is called the higher derivatives. So we are having, for example, if you have seen this, then we can write this is a second derivative. We can write with these notations. So this is the first derivative. This is the second derivative. This means derivative of, okay, or derivative tools. Okay. Yeah, I think the other example here, um, yeah, I think we can skip these examples. And okay, I think um, we can move on and start to have a new chapter, chapter 3. So because we are finished in chapter 2, so whenever time is coming, you need to prepare. Maybe we'll have some quizzes. Okay, like I told you before, uh, I will have some small, probably like it is a quiz, but I will have that as in a small percentage compared with the other quizzes, and I will use the I will use the Google Classroom to make the announcement, and I will make the Moodle for the general announcement. And as I mentioned before, so chapter 1 and 2, probably like a small quiz I will announce at the Google Classroom. Probably taking only 15 minutes to make. So it's like a little quiz, like an assignment. This is actually new tools also for me, but I hope it is easy for you. So what you need to do, um, you need to open link from Google Classroom, and when you have the link, you will get so you will have the interface. Probably it's fill in the name, student ID, blah blah blah, and then you will have the questions here. I'm not sure how it will be looks like, but each question will be showed one by one. So you need to finish each questions. You cannot choose the questions like which one you want to do first. So each question will have time limit. Okay, from 30 seconds to around 5 minutes each one, but mostly it's 1 or 2 minutes. So between this time limit, please solve each question. And if it is possible, also, if you write like in the paper, please write like uh, all the things you are answering. It doesn't need to be really clean. No need to be clean. Okay, no need to be clean. I just want to have um, I just want to know how you are proceed your quiz, okay? Your quiz assignments. Okay, and then after you finish, um, you will need to wait for some time and you will get the results. Okay, but of course, I will check also how you answer the questions. Uh, but still, the the score is based from the online platform that I'm using. Okay, it's okay if you want to open any book calculator. That's fine because you don't have really much time left anyway, right? So yeah, it doesn't matter. So try, okay. And when, okay, um, probably I will have between this week and next week. Okay, I will have like if next week maybe I will have time until the Saturday maybe. Okay, maybe Saturday. Um, between this Saturday, let's say this Saturday, 16 to Saturday, or maybe through Wednesday, Wednesday, 20. Between this, I will announce, and then I will have some uh, time limit for the whole assignment. So you can open anytime between those times. So maybe I will open. Okay. So for example, I will announce on Sunday or maybe next Tuesday. So Tuesday, I will announce on this, and I will give you some times until maybe Thursday before class. So 21. So you have 3 days to fill out the form. You can fill out the form anytime at night. You just need to allow some 15 minutes, maybe 15 to 16. But if you are understand the questions, understand the concept, maybe less than 15 minutes, maybe 10 or maybe 5 minutes. Okay. Okay, so please wait for my announcement. And because of that, um, oh, this is just example. Okay, it can be anytime between Saturday to Wednesday. So anyhow, um, uh, please join the Google Classroom. Okay, if you still cannot join, please let me know on Thursday class. Okay, I've repeated many times, so I hope you at least check how to join. Okay. Okay, let's move on to the next chapter. Okay, differentiation rules are yeah, it's differentiation rules for the title. Okay, let's start with the derivative of polynomials. Okay, let's start with the simplest functions. F of x equal not zero, a constant. So imagine you have a line y equals c. Okay, y equals some number. Okay, from the definitions, if you want to make f prime x, let's write the whole definitions here. And then if we want to make the f prime here becoming using the c, as we have the it's equal constant, it's not equal c, sorry, should be from x, then we can make it into let me just write the f of x is c minus c, okay, which is 0. Okay, so let's start with from the easy derivative. When you have a constant, it will be 0. Okay, similarly, if you have y equal x, okay, or this is equal x, like that, which has the slope equal 1, and also compare with the other x squared, this will result in 1, right? You look at the, it will be having the x plus h minus x divided by h is 1, right? So we will have, this is 1, okay? The other one here will be 2x. And the other, for example, if you have f of x is equal, let's say, x with the power of 4. So if we check with limit definitions, okay, we may have some long expansion for the power of fourth. So let's make a long line here. And this will be x with power of 4, 1, 4, right? 4, 6, 4. And this is going to be there. And then we have solve this, and then this will be 0, 0, and 0. And of course, we will get this is equal to 4x cubed. So yeah, f prime become 4x cubed. As a conclusion, okay, if n is a positive integer, then okay, based on what we have find through the some power rule, okay. So this is power rule. There are some proof for uh, the limit definition. Of course, if we are just saying this, it's not a proof. It's just intuitive definitions. Okay. If we need to prove, we need to have some mathematical concept. But I think I will skip that for now. I will give you later if we have time. Um, okay. Or actually, the second way you can also write if n uh, is any real number. Same thing here. Okay, why I need to write these two different things? Because the first one is based on what we have find through some a different integer, and then we have actually we need to have some proof here that all cases are possible, and then we make these conclusions. Okay, but I will skip that for now. Okay. Okay, let me continue for a little bit. Maybe I will give you the proof, maybe the Thursday class. Let me write this is the basic derivative rules. Okay, C is constant. This is the function itself. This is derivative notation. So derivative of functions, and if we have some constant that can be factorized, we can factorize the constant also. We can also separate this function if we have a multiple function inside, or even we can make a difference like that. That's also possible. Okay. Let me write the product rule. This is if you have f of x and then g of x. Let me write the conclusion first, and then maybe we can discuss later. And the quotient rule. All right. Uh, okay. Okay, I think I can explain one rule here for the product rule. Okay, let me move to the next slide. Okay, let's say we have this is f, the big F, and this is equal with small f and g, fg. Okay, the product, and let the big F prime having the limit definition. Okay, let's start with that. And then try to exchange the function here. Fx plus h is basically f is a product of fg, right? So let's write down. Okay. Now we have this. What we need to do now, the key we need to add and subtract. So plus minus this element this element here. So we have to write down whole limit and let's write down so plus, okay, and minus the same function here. Okay. And then for this, grouping x plus h and gx. Okay. So we can write down, we can group the fx plus h. Okay, so first is gx plus h, and then minus, let's say I will grouping with this minus gx. We'll make, so this is 1 and 2. Okay, this is 1 and 2, and this is 3 and 4. And then this will be divided by h and plus, let me separate the limit, and this will be gx. Okay. Now, provided the limit exists on all conditions here, then we can make this okay. Now you're getting familiar with, right? This will be just f of x, right? You plug in here just f of x. Now this is the derivative, right? So this is g prime x, and plus this will be gx, and this will be f prime x. Okay. So the key is to have this element here, have this element, putting inside the structure of this definition here. Okay. How to get this fx plus h and gx? It is actually, if we look at this, we have x plus h, fx plus h, gx plus h, and in the last terms here, we just have fx gx. So we can also think if we can make another one with this and this. I think it will be resulting similar results. What we want to do is we want to make out that when we have this additional and subtracting, we want to make this. We want to make it happen here. Or just to simplify that, okay, maybe this is having relations with the derivative. All right. Okay, any question here? Okay, so this is just to show you how we get the results for the product rule in derivative. Okay, if there's no questions, as usual, we'll have you having some feedback from you for this lecture. Okay, if you feel any confusion, just let me know and we can discuss next Thursday. Okay. All right. Um, Let me just share screen directly. So let me stop this share screen. Okay, so yeah, you can prepare maybe pen and paper if you like, but I think I just prepared two questions, so yeah, it will be quick. Okay, okay, I will wait for all of you. Okay, all right. Okay, I will start. Okay, good. Please give me your name. Any name should be okay. Should like. Okay, 33 participants. Okay, well, let's start. Um, all right. Okay, consider the graph, and you need to match out the uh, okay. I think the time is a little bit short, right? Let me hold that for a moment. Uh, Sorry for that. I think I already checked this. Yeah, sorry. Okay, let's wait a moment. Let's wait a moment. Oh, yeah. Okay. I haven't saved the last one. Okay. Let's just reset the uh, so if you would like, you can go back and then try to scan another one. I'm not sure how it's going to look like in your phone. Sorry for the okay. Okay. I just reset the this number one here. Okay. So sorry for that. I thought I already changed the time limit. It's not safe. Sorry. Okay, let's just start. Okay. Okay, let's just start with okay. Hopefully it's enough. Okay, around 40 seconds. Hopefully that's enough. Okay. Okay. All right. All right. I think that's it. Mean that you have uh, much time to think. Okay. Oh, people. Okay. All right. Let's see the second question. I hope you're ready. I hope you remember. I hope you remember. I hope you remember. It's just true or false. Okay. You can choose which one. Hope you remember. Okay, 10, 9, okay, 7, 5, 4, 3, 2, 1. Okay. All right. Good. 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 Okay. Uh, who's the winner now? Okay. People, please write down your student ID on the chat box. Okay. So congratulations for the activity, and see you on Thursday. All right. So yeah, you can leave the Google Meet link. Okay. Yeah, you're welcome. You're welcome. Okay. Have oh, attendance link. Wait. Attendance link. Wait a minute. Okay, check this out for the attendance. Uh, if you can use this attendance, I will use another one. Yeah, if you miss out the assignment, you can turn anytime. Okay, as long as it is this week. Okay, well, you won't be able to have a full point. Okay. Okay. How about the attendance? Is it okay, or is it error? Oh, okay. Okay. So see you on Thursday. Okay. See you. See you. Okay. Bye.